In this video, I'm going to go over two questions that somebody emailed me about the material from this first week. So the first question had to do with collinear points and what are collinear points. Well, collinear points are just points that appear on the same line. Now suppose we have 2 points. No matter where those 2 points are, we can always draw a line through 2 points. So imagine that that's a straight line. Now, it doesn't matter where these 2 points are, they will always be collinear. So let's back up. Let's say point B is up here. Now I can still draw a straight line between these 2 points. So any 2 points are collinear because we can draw a straight line between any 2 points. So if the question were to say, are these 2 points collinear, and it gives you 2 points, yes, they will always be collinear. So you're not really going to be asked that very often. In the homework, you were given 3 points. I think they were called P, Q, and R. So P, Q, and R are going to be collinear if the distance between P and Q, so the distance between P and Q, if I add that to the distance between Q and R, that's going to equal the distance between P and R here. So why is that true? So suppose these are the 3 points, and let's just assign values here. Let's say the distance between P and Q is 3, and the distance between Q and R is 5. So what this is saying is if 3 plus 5 is equal to this entire distance, which is 8, then we say that then we say the points P, Q, and R are in fact collinear. So because 3 plus 5 is equal to 8, we would say yes, these 3 points are collinear. Now let's come up with a counterexample. So P, Q, and R here, we can clearly see that these are not collinear. We cannot draw a straight line through these 3 points. And then again, let's assign arbitrary distances in between. Let's suppose this is 5. Let's suppose this here is, I don't know, 4. And then let's suppose this here is 11. Okay? So we can clearly see that 5 plus 4 does not equal 11. So the only way that these first 2 points, the distance in between the first 2 set of points is going to be equal the distance between the third set of points is if they are in a straight line. Now there's 2 other ways, there's many other ways that we can determine if 2 lines are collinear. 2 other ways that we can see this may make a little more sense to us. So these 3 points will be collinear if, again, I can draw a straight line through them. Now, these 3 points will be collinear. Another way that we can prove this is that if the slope of PQ is equal to the slope of QR. So if we pick any 2 points and their slopes are equal to each other, then we would say that those lines are collinear. One other way that we can see if 2 lines, or if 3 points are collinear, and this is maybe beyond the scope of this class, well, the scope of this point of the class, we'll get to this later. But if I have 3 points, and we draw a triangle between these 3 points, let's call this A, B, and C. So if the area of triangle ABC does not equal, well, let's say if it does equal 0, then A, B, C are collinear. Okay, so we can see in this triangle that is drawn here, that triangle has an area, right? It has some area inside here. Now, if those points are collinear, if the points make a straight line, then there's no triangle that can be formed. So the area of triangle let's call it DEF, the area of this triangle would have to equal 0. Now it doesn't totally make sense because if I draw a straight line through these points, no triangle can be formed. But because of that, we would say the area of this triangle is 0. And I want to back up just over here for a sec. This test, if the slope of PQ is equal to the slope of QR, this will work for any 2 points, or the slope of any 2 points can equal the slope of any 2 other points. It doesn't matter which points we choose. If I find the slope between this first set, I could choose P and Q if I wanted. I could choose Q and R as well. Okay, finding the slope between any 2 points. If those slopes are equal, then the lines are collinear. The second question that came to me was, why is this true? Why does theta equal R over S? Remember, theta is just the central angle. R is the radius, and S is the arc length. So suppose we have a circle, and we have the center, the arc length, or I'm sorry, the central angle is here. The arc length is this distance here. Let's call that S. And then the radius is here and here. Now this formula, or this equation, basically is just the definition of radians. So remember, the definition of what a radian is, well, a radian is, or rather 1 radian is the central angle, is equal to the central angle when the arc length equals the radius. Okay, so let's say that this arc length is equal to, I don't know, 2 inches. For theta here to equal 1, the radius must also equal 2 inches. Now let's change this up a little bit. Let's back up a little. Now let's suppose this arc length is equal to 3 inches. Again, for this central angle to have to be measured, or to have a measurement of 1 radian, this radius must also equal 3 inches. Now suppose that arc length is still 3 inches, but the radius is 6 inches. If this is going to be 6 inches, well, now the central angle no longer has a measurement of 1 radian. Now it's going to have a measurement of 2 radians. Okay, so really we're just using this fact. So radians, measuring in radians is really just taking the ratio of the radius over the arc length. So we can use this ratio to then find the arc length. So S is just equal to R over theta. And we saw that. Couple equal signs there. So we saw that the arc length is equal to the length of the radius divided by that central angle in radians. So kind of in general, there's not really a proof here to show that theta is equal to R over S. We just get to this fact by definition, and the definition is saying 1 radian is equal to the central angle, or occurs when we have a central angle equal to, sorry, my dog is barking. Hang on one sec. So what I'm trying to say here is the central angle will have a measure of 1 radian when the arc length equals the length of the radius.